And the final Python data structure we'll consider in this chapter are known as dictionaries. So dictionaries, otherwise known as maps or sometimes associative arrays, they're an unordered collection of key value pairs, which means they associate a label, the key, with the data, value. For example, in a real-life dictionary, it associates a word with its definition. Dictionaries are kind of like lists because we group things up, but instead of having sequential numbers, we're going to use values as the labels. Most commonly, we'll use string labels, but any immutable type will work as the label. The syntax for creating dictionary literals is to use braces, or squiggly brackets as they're sometimes known, to delimit a sequence of key value pairs. So for example, I could say my dictionary D equals, and then in squiggly brackets, I'd say key, colon, value, and then comma, another key, colon, value, comma, key, colon, value. So the keys in this example are the strings red, blue, and green, and the values are the strings fire, water, and earth. So if I created this dictionary literal, it would construct something like this. It's a collection or a set of pairs in no particular order. So if I said D equals all of this, it would create a data structure similar to what's depicted in this image here, where we have 3 pairs, we have 3 keys, and 3 values, and an association between each key and value. So if I ask how many items are in this dictionary, there are 3 items. Even though there are 6 strings, there are 3 pairs. Now the keys in a dictionary can be any type of immutable value. Most commonly we will use strings, but you can see dictionaries with integers or booleans or even tuples if you wanted. Now importantly, these keys need to be unique because each key should identify a single item within that dictionary. So we can't have any duplicate keys, but the values themselves can be any value we want, including duplicates. Importantly, these keys are non-sequential. We don't have to have some first key and then some second key and then some third key, as in a list where we have the 0 index, the 1 index, index 2, index 3. With dictionaries, we just take any keys that we want, associate them with a value, and include them in this data structure. Now because of this, keys are unordered. The order of those keys is not guaranteed. So even though we say red, then blue, then green when we're defining this dictionary, the actual dictionary could store those in any particular order. Now the key and the value will remain associated, so red will always associate with fire, blue will always associate with water, and green with earth, but they can be in any relative order amongst themselves. The values in our dictionary can be any value. We can have mutable or immutable values. We can have duplicates if we want, and then each one of these values, importantly, is associated with some key. So when I say red fire, that value fire is associated with the key red in our dictionary. So when should we use a dictionary? Well, dictionaries make sense when number labels, that is say indices, don't give us enough information about the values we're looking at, or when the order of that data doesn't matter. If they don't need to be in sequential order, we can just put them all in a dictionary and not worry about what order they get stored in. So dictionary operations are fairly similar to list operations. So we've already seen we can use the length of our dictionary, which returns the number of key value pairs. We can access individual elements in our dictionary. So if I say dictionary at some key, it will return the value. So if I say D at red, in this case we get fire. Note we use square brackets just like in a list to delimit that, but instead of using a number, here I'm using a string. So instead of an index, I'm using a key. And notice even when we're doing that, we have to include the quotes because the string itself is still just a string. To add a new item to a dictionary, we just assign to a new key. So we say the dictionary at some new key equals a value. The key doesn't need to exist already in order for the assignment to work. So unlike with lists, where if we attempt to assign to a non-existent index, we get an error, with dictionaries, that's how we expand the dictionary. No need to use the append operation, we can just use basic assignment. Similarly, if we want to mutate or change some value associated with an existing key, we can just say the dictionary at that key equals this new value. So we just assign to an existing key and it changes the value. Note, if we're assigning to an existing key and changing the value of that key, that means we're not creating any secondary copies of that key. That makes sure that our keys remain unique. To remove a key value pair from a dictionary requires a new keyword, the del keyword. So del stands for delete, and you can do this with any variable. This just removes the mapping of some variable, but Python typically takes care of that for us. So you don't normally need to use the del keyword on its own. But with dictionaries, because there's no remove or pop operation, In this case, we use the del keyword, and that destroys one of those key value mappings. So if I said, in this case, del dictionary at red, it removes that mapping from the dictionary. If we want to check if something exists in our dictionary, that is to say if we want to do a membership test on our dictionary, we can do this for keys quite straightforward. We can just say if key is in dictionary, so just using the in keyword as we normally would, we'll return true if the key exists in our dictionary and false if the key does not exist in our dictionary. This is useful if you want to handle new keys in one way and existing keys in another way. So for example, if you wanted to count all of the items in some input, every time you see a new item, you could create a new mapping in your dictionary, and anytime you see an existing item, you could just increment the value in that mapping already. So we can check for the membership of keys in our dictionary quite straightforward, but if we want to check for values in our dictionary, we have to do a traversal. A traversal on a dictionary looks like a normal for each loop, so for key in dictionary means iterate through each pair in that dictionary, and for each one, assign the key of that pair to our loop variable. So if we wanted to get the key and the value, we have the key already. We could access the dictionary at that key to get the value. So I could say for some key in some dictionary, I could print the key out, and then I could print out the value by accessing that dictionary at that specific key. So this simple example would print out all the key value pairs in our dictionary. So that's a fair bit of reference information. Let's do some quick demonstrations in Python to see firsthand how these dictionaries work. So open Python, and I will say my dictionary equals, then a squiggly brace, some key, colon, and then some value. And comma if I want to include more items, another key, colon, and then another value. And you could type more if you want, but let's just make that our dictionary for now. Now if I want to access elements from that dictionary, I could say my dictionary at the key A, and that returns apple. If I ask for the dictionary at key B, that returns the value bear. Now note if I put the values in here, or if I put something that doesn't exist, that's a key error, that value doesn't exist. Similarly, if I ask for one of the values like apple, it tries to use that as a key, and because that's not a key in our dictionary, it's also a key error. Now as I said, these dictionaries are unordered, so if I have my dictionary, which prints out as A apple and then B bear, and said, is my dictionary equal to the opposite of that? So B bear and then A apple. Noting that if we did this with a list, asking for a forward list and a backward list, it would be false, but with a dictionary, this is true because the two orders are irrelevant. If I tried the same thing with the list, is 1, 2, 3, 4 equal to the list 4, 3, 2, 1? That's false, because the order is important with a list, but with a dictionary, these things are non-sequential. The order is not important. Now, a nice thing about dictionaries is that when we're associating these labels with the values can be of any type. So for example, I could create a dictionary that resembles a student record. So I could say some student is equal to, and then I could give their name is Bob Robinson. I could say their age is, we'll say 18. I'll say their CGPA is a solid 11.5. And are they a graduate student? That's false. And this creates a dictionary with all of those different key value pairs. So even though we're not constructing some program where this is useful, this dictionary effectively represents all the details about a single individual person. If we did this in a list, we just have a list that has the string Bob Robinson as index 0, the integer 18 as index 1, the float 11.5, and the Boolean false. Whereas in a dictionary, by associating string labels with each of these values, we associate more meaning within the data structure itself. So quickly to see the other dictionary operations, we can access elements from a dictionary. So I can say student at name, and that gives me the student's name. Notice if I just say student at name without quotes, that's an error because I'm trying to pass in this variable, which doesn't exist. If that variable existed and it held a value, like let's say I had some variable x, which had for some reason the string graduate, I could say student at x, that's fine. Right? That returned false because the value stored in our dictionary at the key graduate is false. So you're allowed to use variables when accessing dictionaries, but those variables have to hold values that match one of our keys, otherwise we get a key error. Or if your variable is empty, then just a variable error. Now if we want to mutate this dictionary, I could say, for example, student at age equals, and then give it a new value, say they leveled up. And now if we ask what's the value of this dictionary, it just changed the value there. If I want to add more information into this dictionary, I could, for example, say student at hobbies is equal to, and then put in some new values. So I'll just say a list of hobbies. We'll say programming and golf. And now if I ask what's the value of this dictionary, it's all the old values plus this new key hobbies that has a value, which in this case is a list that has 2 strings in it. So it's still a key value pair. If we ask what's the key, it's hobbies. If we ask what's the value, it's this list, but then we can access parts of that value as we would access any other list. Notice if I assign something else to this, so if I say student at hobbies equals video games and press enter, it replaces the value at that location. So it takes the existing key and says, oh, now it has this value instead of the value it had. If I wanted to remove information from my dictionary, if, for example, we decided it's not a good idea to store hobbies with student class records, we could say the del keyword and then student at whatever key we're trying to remove, in this case, hobbies. Now if we ask what's the dictionary, that extra key value pair has been removed. And lastly, if we want to traverse these dictionaries, we can say for key in our dictionary, let's call student. Then we could just say print, and I'll say k, bit of formatting equals, and then our dictionary, which is student at k. And that iterates through our dictionary, printing out key equals value. So to test our understanding, let's try a comprehension problem here, bringing up a little variable table. So we only have one variable again, just to keep track of our dictionary, but we have a dictionary where our keys and our values are both integers, which, as you might imagine, is a cause for some confusion. So the first line says, define this dictionary. So we have this dictionary called nums, and it has the following keys and values. I'm going to say keys, like this. You can write this however you want. I'm going to put mine in a bit of a table here. So my keys are 2, 5, and 1, and my values are 4, 6, and 3. Notice I have no indices here because the keys represent the indices, so to speak. They're the way of representing the labels of our data. Now, the second line here says nums at 1 equals nums at 2. So again, that's not nums at index 1, that's num at key 1, which does exist, equals the value of nums at 2, which also exists. So that says go into nums at 2, get its value, which is 4, and store that at location nums at 1. So this becomes a 4. The next line says take the value of nums at 3 plus 2. So 3 plus 2 is just basic math. Just because it's in square brackets doesn't change anything. So 3 plus 2 gives us 5. So we say nums at 5, which is the value 6. And we assign that to nums at 3. Now there is no key 3 here, so that means we're creating a new key. So I'll add a new key here, and we'll take the value from nums at 5 and copy that. Then the next line says nums at 3 plus nums at 2. So nums at 3 is 6, nums at 2 is 4. Add those together, so 6 plus 4 is 10, and store that in nums at 6. So over here, again, there's no key 6, so we make another new one, and we store the new value, which we said was 6 plus 4, so 10. Now, this code doesn't actually do anything to print the result, but if you wanted at the end of that, you could say print nums, and if you're running this code, you should get a dictionary that looks like this. Now, remember the order of that dictionary might be different. Your first key might, for example, be 5, but the value associated with that key should still be the number 6. And to finish off this whole chapter, we have one more programming task that asks us to translate a sentence into the NATO phonetic alphabet. So write a function that accepts a string as an input and returns a translated string, which uses the NATO phonetic alphabet, which is Alpha, Bravo, Charlie, etc. So given some string, we want to translate each character in that string into one of these phonetic descriptions. So if our input was hello, our output would be HELLO as the phonetic words, hotel, echo, Lima, Lima, Oscar. Now I've pre-written a dictionary which already contains this mapping from letters in English to the phonetic alphabet. So now all we need to do is construct the function, the translate function, which will take in a string using this dictionary translated into some output string. So let's come down here and say def translate, which takes some input string, we'll call it S. And now this function will translate an input string to an output string using the phonetic alphabet. So in terms of a design, how are we going to do this? We have some string S, and we need to do something to each individual character in that string. So we need to traverse that string and check each character against the keys in our dictionary. If it's an H, for example, we want to turn that H into hello. If it's a P, for example, we want to turn that P into papa. If it's a W, we want to turn it into whiskey. So we need to have some sort of result output that's going to collect these translations so that we can return them all. And beyond that, we're just traversing and translating. So let's start with our results, initialize to an empty string, and then we'll traverse our string. So for character in string, for C in S, says for each letter in the input. So now each time through this loop, the variable C will contain one character from our input string. It'll be the first index, and the second index, and the third index, but the characters themselves, not the indices. Now if we have a character, let's call it the letter G, and we want to get, instead of the letter G, the phonetic translation of that, Gulf, all we have to do is refer to our dictionary using that character as the key. So if I said G as my key, then the value in that dictionary is Gulf. So all I have to do is pass that through. So I could say phonetic, it's the name of my dictionary, at C, and that will translate whatever letter into whatever word. So now all we need to do is take that word and attach it to our results. So we'll say result plus equals. So we're using concatenation here to join strings, so there's no conversion necessary. Now if the input is one word like hello, we have H, and then right next to it an E, and right next to that an L. In the output, we want them to be separate words. We want them to be spaced out a little. So we want hotel, and then next to it echo, and then next to that Lima. We don't want them to be scrunched together all as one big word. We want to have separate words. So the only other thing we need to do is include a space after we've translated the words. And when we're done, we can return the result and test it out. So I'll say translate the string hello. We'll run our code. So we'll say Python phonetic.py, and nothing happens. As per tradition, I have forgotten to output my demo code. So we output, and we can see Hotel Echo Lima Lima Oscar. Great. That seems to work. But what about punctuation, spaces, and capitals? So what if I tried print, translate, data structures are fun, exclamations. Save and run our code again. The first one worked. We get Hotel Echo Lima Lima Oscar as output. The second one broke, and it said key error uppercase D. So uppercase D is literally the first letter in our string, so we didn't make it very far into the second one and it broke. So what's the error here? And see if you can try to solve it before we work together to solve it. So our error says key error uppercase D. And if we look at our dictionary, through all the keys in this dictionary, we have A, B, C, lowercase d, E, E, F, G, all the way to Z, but we only have lowercase keys as our dictionary. And noting that upper and lowercase are very different strings, Python doesn't really have a way of knowing one is associated with the other, so it's not going to make that leap in logic for us. We're going to have to tell it to make sure that if we get uppercase letters, we need to be able to handle those as well. There's a few ways we could solve this. We could expand our dictionary to include all of the uppercase letters as well and have those convert to the same values. It would make our dictionary quite a bit bigger and be a bit of work to type it all out. Another way to solve this is, as we're traversing our string, let's just traverse a lowercase version of that string. So instead of for C and S, we can say for C and S dot lower. And now C is going to be the lowercase version of all of those. So when it gets uppercase D as its first letter, it's going to be lowered and then put into the variable C. So it'll be a lowercase d, which will associate with the word delta in our map. All right, let's see how far we got. Save, run our code again. We get a different key error. So it's a key error, but now it's on the value exclamation mark instead of on the value D. So again, we're trying to access this dictionary because the issue in both of these cases is we're assuming the values we're getting from our input string, the variable C here, are in our dictionary. And if they're not in our dictionary, then the code breaks. So what we should be doing, rather than just accessing these variables right away, is checking to see, is it okay to access these spots of our dictionary? If so, then we'll do the translation. And if not, then we'll handle that gracefully in some other way. So instead of just immediately saying phonetic at C, we'll say if C is in phonetic at all, if the key that we're looking for is in this dictionary, then we'll do the translation. But if it's not, well, we'll just put something in there. We'll just say result plus equals, and we can take the letter that we got, for example. So if we get an exclamation mark, it'll put an exclamation mark in the output. It's possible we could just say do nothing. So instead of putting C, we just leave a blank, and that would just strip away all the extra punctuations, but this is fine as well. All right, so we got our first output, which was hello, and then our next one, delta, alpha, tango, alpha. Data structures are fun, with exclamations. And that's dictionaries in a nutshell. So again, dictionaries are unordered data structures. They're a way of grouping data together without having to worry about which one's first, which one's second, which one's third. And instead of associating indices with them, because again, there's no order to them, we're just going to associate labels, which gives us the ability to associate more complex labels, like representing, for example, all the attributes of a student in our student dictionary. That's it for this topic, that's it for this video, and that's it for this chapter. So in this chapter, we covered a lot of different things about data structures. So we saw we could group data into ordered sequences called lists. We saw that strings themselves act a little bit like ordered sequences or like lists. We learned about tuples, or tuples if you prefer, which are like lists but immutable. We learned about references and the issues of aliases that those can cause if we have mutable lists. And we learned about dictionaries, this unordered data structure for storing things in key value pairs. All right, that's it for this video, and I will see you in the next one.